Hello, welcome back. In this segment, I wanted to show you an important property of group exponentiation. Okay. To motivate, I wanted to bring a concrete example. So the question is, what is the value of 2 power 405 when divided by 23? What is the remainder? Percentage means remainder. Okay. In this case. So this is not that trivial, right? Because you need to compute 2 power 405 first, and then you divide it by 23, and then look at the remainder. But I'll show you a nice trick from group theory that you could use to compute this much efficiently. Okay. So remember this as a motivating example. We will solve it without using a computer program, and then we will confirm our results are correct using a computer program. Okay. All right. So let's go as follows. Let's assume we are given a group G, a finite group. Any group. It can be additive, multiplicative. We don't care. It's a group, and we are given a group element G. Okay. Let's assume the order of the group is G, meaning let's assume the order of the group is M. Okay. What it means is that the number of elements in the group is same as M. Okay. G is a group element. A group means a set with a bunch of operations like closure, associative, identity, and multiplicative universe. We talked about that earlier, so I will not revisit that. So you are given a group element, and you are given some integer which may not be in the group. Okay, and your goal is to compute G power X. Okay. The theorem says that instead of computing G power X, you can compute G power X mod M, which is nice because mod M will give you a number between 0 and M minus 1. So you have a much smaller number to exponent, to raise the exponent. Okay. All right. So this is the theorem. We can easily prove this theorem now as follows. I'm going to make use of an elementary fact from pretty much from high school. So if you're given two numbers, say A and B, okay. If you're given two numbers A and B, you can always write A and B as follows, right? A is equal to Q times B plus R. Q is the quotient you get when you divide A by B, and R is the remainder. Okay, this is always possible for any two integers, assuming B is non-zero, of course. Okay, so we can make use of this fact. R is the remainder when A is divided by B. That means R must be a number from 0 through B minus 1 inclusive. Okay. So this is the fact that we will leverage to prove this theorem. Okay, there is another interesting fact we need to use. For any group G, we already proved this fact actually. G power M is 1. If G is a group element, M is the order of the group, G power M is 1. These two facts we will use to prove this. Okay, let's consider the proof now. Let's take G power X, left-hand side. First, I will write the exponent as follows. So the exponent X can be written as Q times M plus R. This is always possible, right? Given X and M, you can always find Q and R because of this theorem. Okay, this is called the division remainder theorem in number theory. So given X and M, we can write, we know X and M, right? They're asking us to prove G power X is something. We are given M, given X. So X can be written as Q times M plus R. Okay. And now we will do G power X. So what is G power X? That must be same as G power QM plus R, right? Which is same as Q power G power M power Q times G power R, and this is nothing but G power R. The reason being G power M is 1. Okay. So what is R? R is nothing but the remainder when you take your X and divide it by M. So we proved it. G power X is nothing but G power X mod M. Okay. So it's easy to compute G power X in this way, right? Because you first reduce your X by mod M and then apply G power on it. Okay, now let's talk about this problem that we would like to solve. So what I'm going to do is, instead of computing 2 power 405, the theorem says as follows, right? We need to compute 2 power X mod 23, right? That's what we need to compute. X is a large number, 2 power 405. Okay, where X is 2 power 405. So we know that this is same as computing 2 power X mod 22. Okay, this is important. It's not 23, it's 22. Reason being the group. Okay, let me explain why I say 22 here, mod 23. Okay, so what group are we working with? We are working with the group 23. 23 is a prime number, and we learned earlier that Z star 23 is made of numbers from 1, 2, 3, all the way until 22. There are 22 numbers in this group. All elements that are relatively prime to 23, below 23 are in this group, which means the number of elements in this group Z star 23 is 22, which is the order of the group. Okay, this is the M that we talked about here. M is the order of the group. Okay, now we need to compute X mod 22. What is X? X is 2 power 405. This part is the X part. So how do we solve that subproblem? Okay, so now consider this 2 power 405 mod 22. How do we solve this problem? Well, now you have to think about the other group 22. Okay, multiplicative 22 group. We can write 22 as Z star 22 as follows. It contains all odd numbers from 1 through 21 except number 11. So the order of the group is 10. Okay, which means instead of computing 2 power 405 mod 22, I can compute 2 power 405 mod 22 is same as 2 power 5 mod. What is the order of the group? 10. You will get a reminder 5. That's the definition of mod 10, the last digit. So this is nothing but 2 power 5 mod 22. Okay, so 2 power 5 mod 22 is nothing but 10. Okay, so we solve the sub problem, and now we can go ahead and put it here. So we have 2 power 10 mod 23 is the problem we need to answer, and 2 power 5. Okay, this is the sub problem. Just to be clear, we already solved the sub problem. That's the reason we have the 10, which we put it here. Okay, 2 power 5 is 32. 32 mod 23 is 9. 9 into 9, 81. 81 mod 23 is 69. 12. Okay, so we got 12. So this is 12. So the answer for this problem is 12. Okay, 2 power 405, when it's divided by 23, the answer is 12. So we can write a quick Python program and check the results. Power of 2 power 405 mod 23. Okay, answer should be 12, which is what I said on the whiteboard. But let's do it in step by step as we use the algorithm. First, we need to compute 2 power 405 mod 22. Okay, let's do that. 2 power 405 mod 22, which is 10. And now we can go and substitute this 10 in mod 23, which is 12. So we got the answer 12. As you can see, we can first reduce the number and then compute the power. Okay, that's basically it.